Okay, today is a review day. Yesterday was a review day. And tomorrow's going to be a review day. And then the test is Friday. So, if there's something that you still don't understand yet, it's okay. You're not supposed to be perfect yet. Okay? So, this one, though, we have practiced enough that I'm pretty confident. I'm going to call on a random kid, and I'm thinking that I'll probably hear the four things in the right order. But I guess we'll find out. Here we go. And it is Brody. The dice of destiny chose you. So number one, what do you think is first?
Reflect over the line.
All right, so you're starting with, let's make sure you understand which one you're starting with. You started with the inside, which I like. I agree. That is a reflect. Now, I hope you were starting with that one. Is that what the one you meant?
Yeah.
Okay, so that one is a good one to start with. Now, reflect, I would not say over the y or over the x, because in my opinion, it's safer to say horizontal or vertical. Now, when we're on the inside, that's horizontal. You can just put an H, reflect horizontally. Now, is that over the x or is it over the y? Well, let's just really quick, if you had to, because they told you that it was over one of those axes, here's how I'd do it. I'd write out, here's my x, here's my y, and that's horizontal. It's on the inside, so that is going across the y-axis. Yup. Horizontal goes with across the y. All right, number two. And the wrong seating chart out here. Sorry about that. And this is Jackie. All right, and since these two are tied, I would allow you to start with stretch, or you could have said reflect, but either way, vertical, stretch, BFO2, by a factor of 2. Very good. And also reflect, and it could have been reversed because they're the same number. Like, and then that's negative is the reflect, that 2 is the stretch. So you could have said reflect first if you wanted to. And I'm going to reflect vertically. And last but not least is up 7. Now, some of you are like, but the key was different. Okay, and here's where you have to grow up and understand that there is nuance. There is, like, you don't say always or never very often in the real world. I always want you to start with the inside, but you don't have to. So this could be moved to last. If we did all of the outside stuff first and then reflected it horizontally, it would still be okay. Okay, so I've said I want the inside first, and that's what I'd love for you to put on your test. But if you by accident do all the outside stuff first in the right order and then do the inside stuff, that's what the person who made the key likes to do, and it's mathematically okay. You can do all of the horizontal stuff and then the vertical, or you could do all the vertical and then the horizontal. I know, it's tricky, but I didn't want to try to explain that to you all at once. Be a little bit like the little kid where you just tell them, don't talk to strangers. And later you say, unless you have to talk to a stranger, and in that case, you probably should pick somebody that's like a police person or maybe somebody who's running a store because they're not as likely to be a bad person, and so you can trust them more, so because it's complicated. At first, I just told you do the stuff on the inside first. Now I'm telling you, you could do the outside first, but that's just not how I would do it. Okay, here's another topic that you're supposed to be good at by now, domain and range. Would you agree that's an upside down parabola? Do you agree that it doesn't go forever in all directions? Okay, so if this is the point 7, 2, you should be able to tell me what this guy's domain and range is. Domain is the x's, range is the y's. Be careful with parentheses and brackets because they're different. Pause for a second. Will you try this one? Okay, for the domain, you should have said, domain is about going this way and this way. And if you let this one run free, it'll continue and keep on going left, and it'll keep on going to the right. Negative infinity to positive infinity. You can use the INF or you can use symbols, and there you go. No brackets, because you can't touch infinities. But on the other one, on the range, it's a bracket because it goes from one thing to another. But, oh, it's really common to go 2 to negative infinity. And what's wrong with saying that? The small number has to be first. What's small? 2 or negative infinity? Negative infinity. You have to have the negative infinity first. It's a rule in math that the smaller number must be first when you have an interval like this. And negative infinity is definitely small. All the way to 2. And there's a bracket on the 2 because it touches 2. Okay. Next kind. You had some of these on your homework, and I know they bothered people. Let's say this is a square root. Let's say it hasn't been stretched. There's no stretch here, but it's at 4, 1. You should be able to write the equation for this because it's been moved. Well, if you didn't know that the original one starts there, it might be hard for you, but I think you do know that. So you'll be able to say this function is y equals the square root of x. Don't just say f of x. That implies you don't know what the function is. Square root of x is what the function is, but it's been moved right 4 and up 1. Notice that plus 1 is outside of the square root. Raise your hand if you had that one right. Okay, awesome. Now, let's say that it's been stretched up twice as tall as normal. So in other words, how do you tell if it's been stretched twice as tall as normal? You're supposed to be able to go over 1 and up 1. Over 1, up 1. But this one seems to be going over 1 and up twice that far. There's a vertical stretch. That 2 there. Yes?
How do you know when you look at a graph it's horizontal or vertical stretch?
All right. I do understand how it can be confusing about horizontal versus vertical. We are not going to confuse you because we could. There's like, for example, what he's asking about is, let's say that we got a parabola that looks like this, is a normal parabola, that's f of x. And then I say, here is your new parabola. Do you get that I could have made my original one narrower, or I could have stretched it upwards and it'd be the same thing? So how can you know? You can't, and we won't. We won't confuse you like that. All right, so here's the kind we could put on a test. So here's that square root function again. But this time I say, instead of going over 1 and up 1, we're going over 4 and up 1. So that's the point 4, 1. Do you get normal would be over 1, 1? And this is over 4, 1. You have to go, oh, so you're saying the x number changed. So that's a horizontal change, not a vertical change. Should be at 1, 1, but it's not. It's at 4, 1. Okay, I know those can be confusing, and you've got some in your homework, and if you're stuck on those, you're going to have some work time today, and you can come up and ask. Okay, here's your next kind. You're given a complicated equation, and you have to pick what points to put in. A lot of kids just like pick random numbers like, okay, I'm sticking in 0. Terrible idea. You think carefully about the inside part of the function, and you choose something that makes that really small or even 0. So what would be a good call on a starting number? 4. Good choice. And always don't put it at the top of your list, because then you're going to pick things that are on either side of that. And then some of them will work and some of them won't. All right, so try 4. You should be able to get an answer for that. Then try 3 and see what happens. Then try 4 and see what happens. happens, and try 5 and see what happens. And so maybe try 3, 4, and 5. And I'm warning you, some of them work and some of them don't. You'll have certain ones where you'll go, that didn't work. You'll have a whole bunch of choices, but notice I started there. And then I tried numbers around that. Now some of these will work nice, some of them won't. You're going to compare in a moment with the kid next to you and say, yeah, 3 didn't work, but 5 worked, and 8 worked pretty good, and etc. For example, I put in the 3 and I go, square root of -1. Wait a minute. Can't do square roots and negatives. That's out. See what I mean? Can't graph something that's imaginary. There is such a thing as imaginary numbers, but they can't be graphed. All right, give that one a try, and in a moment, I'm going to ask you to compare with the kid next to you. I'll be more specific. You should have realized that 4 works well, 5 works well, and 8 works well. Those 3, compare with the kid next to you right now, please. So when I put in 4, I get square root of 0, which is 0. 0 times 4 is still 0. So I get 4 comma 0. When I put in 5, I get 4. When I put in 8, 8 minus 4 is 4. Square root of 4 is 2. 2 times 4 is 8. If I graphed these over 4 up 0, over 5 up 4, over 8 up 8, what the heck? This thing is almost going straight up. Well, it's because it's been stretched. Not only did it get moved over 4 to the right, which was this part, it also has been stretched heavily with that 4 in the front. Vertical stretch by a factor of 4. Okay. Oh, wait. Now, since that's the point 4 comma 0, what's the domain and range of this thing? There's domain and range questions all over on this test. Domain, does it go forever in both directions, left and right? No, you can't put in things like 3, because if you do, you put in like a 3, you get imaginary numbers. So the domain starts at 4, goes to infinity, bracket on the 4. Okay. Then the range is from how low to how high. The lowest it goes is 0. The highest it goes to is infinity. And I'd always go back and make sure I put the smaller number first, which I did. So yay, there we go. Temperature check on that one. Raise your hand if you had that one right. Okay, good. Domain and range are good apparently. So what else is on this test? This is the nastiest of all of the functions, 1 over x. Did everybody sketch it? You should know what that thing looks like. And the domains and ranges on these are awful. But I'll talk you through one. So remember what domain means. In the context of a graph, it's how far does it go to the left and how far does it go to the right? Is there any numbers that it like skips over? Well, here's what the graph looks like. Now this is getting closer and closer, but never touching 0 this way or this way. So this is called a horizontal asymptote. And it seems like it should be it is the x-axis, but that seems like it should be x equals 0, but it's y equals 0. The x-intercepts are where y equals 0. That's that line. This line is going up and down, that's x equals 0. It's the y-axis. It's kind of counterintuitive, but... All right, now... What if I asked you for the domain and range? Well, does it truly work for every single x number you could ever put in? How far to the left does it go? Negative infinity. It works there. And then it keeps working all the way until it hits something, and then it doesn't work. Then it starts working again, all the way to infinity. See if you can finish off. I've started the domain on this. And then the range is very, very similar. Try to do the range the same way. The research shows, if I let you struggle with this for a minute, that if you don't know how to do it, that'll set the stage for hearing the answer and remembering it better. So I'll pause while you try hard on this hardest domain question there is. Okay, domain is from left to right, and it goes forever to the left, and then as you think of coming back and going across this graph, it's working, and then all of a sudden it tries to avoid touching 0. So that's the thing it can't be. It can't touch 0. And then it starts working again here, and it keeps working forever in that direction. So that's, again, 0 to infinity. Plus, you need a little u for a union in between the two. All right, range, same thing, except it's from low to high. So the lowest it goes is negative infinity. The highest it goes, well, you can't get that right away because as you're coming up from down there, it also doesn't want to touch something. It doesn't want to touch 0. So it's exactly identical. This little union is just a symbol that means the two things together are your answer. This together with that. That's what union kind of means, is together with. All right, that was hard, I know. Now I have to make it even more complicated. Let's move it up a little bit and over a lot. Let's say it goes over 8 and up 3. Now it's graphed here. Now what's the domain and the range? All right, I wish I could just go really slow on these and take a long time to make sure you understand, but there's so many concepts. I need to keep moving. The domain, from left to right, it does go forever in both directions. It's just that there's something along the way here that stops it, and that's 8. So it's negative infinity up to 8, union 8 to infinity. Raise your hand if you had that one right. Sweet. Then the other one's probably right, which goes from negative infinity up to 3, which is what stops it vertically, and then 3 to infinity. Okay. Next. I'm trying to make a point here. If I graph those dots, can you tell where the line should probably go? Well, yeah, I graphed a lot of dots. You'd probably be able to tell, right? What if I just graph 2 dots? Can you tell, especially if I say there's a curve going through them, can you tell at all where the curve is? No. I could even put 3 dots and say, can you tell where the curve is going through them? No. But what if I graph 5 dots? or 6 dots. Now you can go, oh yeah, it's one of these graphs that goes like this. The other one's going like that. And there's probably an asymptote that goes in there, and an asymptote that goes in there. I know I didn't draw it perfect. My point is the more dots you have, the better. So if you're graphing on the test and you're like, I can't see where this thing should go, graph more dots, get more points. Get enough points, you get like 6 points, everybody can see where it is. I mean, there's no way if I graph something with 6 dots, you guys will be like, oh, clearly it's going like that. You know, like you have to see it eventually. So graph more dots. All right, so here's one where you might not see it at first from just 1 or 2 dots, but get yourself a bunch. And some kids are going to go, Mr. Server, it's impossible. It's a trick question. Can't have negatives under the square root. False. If you pick the right numbers to put in, you can absolutely have a negative there. You just better choose wisely what x's you use. And is 1 dot enough? Of course not. You can't tell where the curve's going. 2 dots isn't enough either. 3 dots, you start to get there. 4 dots, you probably have enough to see where the curve is going. So graphing points, definitely on your test. And I've had a lot of kids ask me, I'm not sure how to start these. Look on the inside, try to make the inside really small or 0. And then go from there. So if you stuck in a number like 1 and it seemed to work for you, in this case 1 wouldn't work, but pick a number close to that. Find one that works and then pick something else that's kind of close to that. Somebody help out here. What would be the first, let's say it this way. What's the smallest number that works but doesn't cause you to get like an imaginary answer? Smallest number you can think of. Yes? Excellent. -1 does work, but it's kind of hard to argue whether something's smaller or not. Would you agree that 0 also would work? So 0 works, -1 also works, and now find a bunch of things that work. Because the more dots you have, the better. And then graph your dots and see if it looks like you would expect it to look. I would be expecting one of these, except flipped in a certain way that I hope you know. And the shrink part, it's kind of hard to know, except it's not as tall. So I'd be thinking, okay, I think it should be kind of like this, but then shrunk to not be vertically as tall. So maybe like that. That's kind of what I'd expect. See how I thought that through? Now, that's not exactly right. I got to get dots. All right, so I'm going to call on some kids to give me some dots. John Paul, what'd you put in? What'd you get?
I put in -1.
-1 got you. 1/4 is correct. And you could use 0.25 if you're uncomfortable with graphing 1/4. Graph 0.25. It's just not, it's not even close to 1. It's a small amount. What else did you get?
There's -4.
-4, I like it. And that becomes the square root of 4, which is 2, and then half, or 1/4 of 2, which is 2/4, which is a half. Very good. And then you got, if I could make that square root of 16, that'd be pretty cool. But I can't actually use 16s. I got to use -16. And then negative of -16 will be 16, and then square root of 16 is 4, and then 1/4 of 4 would be 1. There's 3 points. Is there any more? Yep, there's lots. And the more you have, the better. Would you agree we can put in 0?
Yeah.
Yeah, a lot of people think 0 is a problem. 0 is not a problem number, unless it's on the bottom of a fraction. 1/0, that would be a problem. But it's not a problem here. 0 works great. It's just 0, 0. And look at that, it's right on my graph. And negative 1 comma 1/4, it's right on my graph. And negative 4 comma a half, it's right on my graph. And negative 16 comma 1, I guess I'd be like way over there. It worked. I've got points on my graph. And they go where I kind of expected it. All right, here's another one where kids, I understandably get stumped with, like, I'm not sure what kind of numbers I should put in here. Just find me 3 logical points. And yes, there can be fractions, like 3 1/2. I don't know where to start. Start by making the inside really small. By what you put in, try to make it come out to 0 or almost 0. Question, sir?
Wait, will there be circles on this list?
Yes, circles is something that's on your review packet, and then we're going to be reviewing it in just a second. All right, so for right now, I hope you've tried putting in 8. At least you should have thought about it. Do you get that you have a 0 on the bottom of a fraction, though? So if you put in 8, it actually is something. It's the asymptote. I know on the other ones I said try not to let it, have a 0 on the bottom. And this is one where you could have a 0 on the bottom, but that makes the asymptote. I don't expect you to spell it accurately, but that's where the asymptote line is, at 8. Isn't that handy to know? It is. I know some of you, I totally get why some of you were like, 8 doesn't work. Okay, but it doesn't work in a particularly awesome way. It doesn't work because that's the thing that makes it over 0, and that's the thing that's the asymptote then. There's only one thing that doesn't work in this whole function. You can put in any number you want, except 8. Every other number gets you an answer. Do you get how that makes that 8 special? That's the asymptote then. Any other number works. Just, they may give you weird decimal answers, but they work. So I'm going to try 9. And then something else near 8, which would be probably 7. And maybe 10. All right, so here's me putting in 9. 9's going to work pretty good. So I put a 9 here. 9 minus 8 is 1. 1 divided by 1 is 1. Then I make it negative, so it's negative 1. Negative 1 plus 3 is 2. We had 9 comma 2. Awesome. Now look where that is. 9 comma 2 is up there. All right, now let's try 10. So if I put in 10, I have 10 minus 8 is 2. That's 1/2. Then it's negative 1/2. Negative 1/2 plus 3. 2 1/2. I can't really see it yet, Mr. Server. I can't either. But do you get if I get enough dots that it'll make sense? All right, how about this? What did you get when you put in 7? Just somebody help me out.
4.
You guys agree with 4? Okay. So 7 comma 4 is like down here. All right. My guess, since I know this is at its heart, it's a 1 over x function, but it's been flipped. Here's what a 1 over x function normally looks like. This has been flipped. It should look like that, but it's been moved way to the right and up 3. So it should look like the blue one, except moved way to the right and up 3. So here's my up 3. Wait a minute. Maybe down 3 because of this negative. Ooh, that's messing with my head. Let me think. Flip it. Ah, I need more dots. I'm putting in 11, putting in 12. Did anybody put in 11 already? Okay. So I'm going to put in 11 here. 11 minus 2 is 11. No, 11 minus 8 is 3. So that's negative 1/3 plus 2, 2 2/3. 2.6. 2.7 maybe. Then I put in 12. And I get 12 minus 8 is 4. Negative 1/4 plus 3 is 2.75. Okay. If I get enough dots, eventually I can graph this thing.
Mr. Super,
Yes.
will you ever give us a question like this on the test? Like with like 100 decimals?
I would try to avoid it, but I would promise you there'll be a decimal somewhere on your test.
Yeah.
Just, there won't be tons of decimals. I will say this. This is a particularly nasty one. Doesn't mean that we won't have anything hard, but there probably wouldn't be one with this many decimals on the test. Okay, so I want to free up a bunch of time now for working on what? Well, you've got this review packet, and I totally get you couldn't finish it last night. It's good because you needed something to do tonight. So you'll have reviews all the way till Friday, and then Friday's the test. So today would be a great day to come up and ask me questions. There's a new worksheet that's been assigned for today, but I couldn't even open it last hour because the Schoology wasn't working. So, excellent, good. So then work on that one. Let's look, and I can probably delete a couple. Wait, this way. I can probably delete a couple. So can you short key? Thank you. Scroll it up. And up further, up further. One more time. Holy cow, okay. This, I'm not gonna delete any, but this isn't gonna be due until Friday. So what day is it now? All right, so you got Wednesday, you got Thursday, and you gotta get it in by Friday morning. Okay, so you got a couple nights to work on this. So bring them up if you have any questions on them, wanna help. That's all I got for you for the video for today.